Choosing the wrong instrument can cause inaccurate measurement and system failure. In this video, I'll explain a 7-step method to select the right industrial instrument. In the previous module, we have discussed industrial software system including Modbus monitoring software, SCADA integration, and data logging software. That module helped us understand how industrial data is monitored and managed through software platforms. Now, we are entering a very important stage of application engineering, and that is instrument selection. In real industrial situations, customers rarely ask for a specific model number. Instead, they explain a problem or requirement. For example, we need to monitor temperature in our pipeline, or we want to measure humidity inside a clean room. Your job as an application sales engineer is to understand the requirement and recommend the correct instrument. To do this effectively, we follow a structured method called the instrument selection framework. For this, step 1 is understand the customer requirement. The first and most important step is understanding the customer requirement. Never jump directly to recommending a product. Instead, ask question and understand the problem clearly. Important question includes what parameter needs to be measured: temperature, humidity, pressure, level, flow. Also understand the purpose of measurement. For example, is the customer monitoring the process or controlling the process? This information helps determine the type of instrument required. Step 2 is understand the application. Next, we must understand the application environment. Every industry has different conditions. For example, a clean room in a pharmaceutical company, a furnace in steel plant, a chemical storage tank, a compressed air pipeline. Each application requires a different type of instrument. For example, high temperature applications may require thermocouples. Clean room monitoring may require high accuracy humidity sensors like ITD. Water tank level monitoring may require ultrasonic level transmitter. So always ask the customer, where will the instrument be installed? Step 3 is understand the environment. The environment conditions also play a major role in instrument selection. Industrial environments may include high temperature, dust, moisture, chemical exposure, outdoor installation, and hazardous areas. For example, a sensor installed outdoors must have proper IP protection rating. A device used in explosive environments must be flame-proof or ATEX certified. Ignoring environmental conditions can lead to equipment failure. So always verify the installation environment. Step 4 is define the measurement range. Every instrument operates within a specific range. For example, temperature sensors may operate from -50 degrees Celsius to 200 degrees Celsius or 0 degrees Celsius to 500 degrees Celsius depending on the technology used. Pressure transmitter may measure 0 to 10 bar, 0 to 100 bar, or even higher. If the instrument range is selected incorrectly, the measurement may become inaccurate or unreliable. So always confirm the required measurement range with the customer. Step 5 is accuracy requirement. Not every application requires extremely high accuracy. For example, room temperature monitoring may allow small variations, but pharma manufacturing requires very precise measurement. Accuracy requirements determine sensor type, instrument quality, calibration standards, and higher accuracy instruments usually cost more. So understanding this requirement helps select the right balance between performance and cost. And step 6 is installation method. The instrument must physically fit into the process. For example, temperature sensors may require threaded probes, flange mounting, insertion probes. Pressure transmitters may use 1/4 inch BSP connection, 1/2 inch NPT connection. Level transmitter may be installed from the top of the tank or through the sidewall. So always confirm how the instrument will be installed. Now, let us combine all these factors into a simple decision-making framework. Whenever you select an instrument, think about these 5 points: application, environment, range, accuracy, and installation. If you analyze these 5 factors correctly, selecting the right instrument becomes much easier. This approach helps engineers to recommend reliable and suitable solutions for their customer. So let us take a simple example. A customer wants to measure a temperature in hot oil pipeline. And first, we understand the application, temperature measurement in an industrial pipeline. Next, we check the environment. It is a high temperature process. Then we check the range. The customer says the oil temperature is around 300 degrees Celsius. Now we check the accuracy requirement. Industrial monitoring standard accuracy is acceptable. Finally, we check installation. The sensor will be installed using a threaded thermobell in the pipeline. Based on this analysis, we recommend a thermocouple sensor with the suitable probe design and a temperature transmitter. This is how structured analysis help to select correct instrument. In this module, we have learned about how to select industrial instruments using a structured approach. We discussed the key factors like customer requirement, application, environment, measurement range, and accuracy requirement. Also, installation method. This structured approach helps engineers to provide professional and reliable recommendation. Instrument selection is one of the most important skills for an application engineer. Customer trust engineers who can understand their problem and suggest the right solution. By following a systematic method, you can confidently design solutions that meet the customer needs. In the next module, we will learn about industrial problem-solving solution design, where we will apply this framework to real industrial scenarios. So thank you so much for watching. See you all in my next video.